Okay, let me double check that this clicker works. It does. I know that it's the afternoon, so we're kind of like a little sleepy here, so I'm gonna try and bring the energy for folks. If it's too much, you're just gonna have to withstand it, I'm sorry. I'm not gonna apologize for it. So yeah, my name is Lisa. Great introduction, thank you. You can scan this LinkedIn code if you want to find me on LinkedIn. The reason why I do the code is because I have a middle name that has an initial called N, and LinkedIn can't find me unless you include that N. There's something in the water there against me. But yeah, so I'm from Datastrato. We are maintainers of an open source project called Apache Gravitino. We're still an incubating project. And I'm really excited to talk about kind of the ways that metadata can be used to power data architecture. I also do some work in the community, so I'm part of OPEA, which is the Open Platform for Enterprise AI, as well as the Continuous Delivery Foundation, which their most popular project is Jenkins, and a WTM ambassador. So who here has worked with data architecture before in some capacity? Yeah? And who here knows what data mesh is? Okay, so we're gonna start from the beginning. If anybody needs me to clarify anything, please let me know. I'm very happy to go back and step around. I also apologize about how bright this is. I'm hoping that you can read it, but I'm gonna try and read some of it for you. So a lot of what data architecture is trying to solve right now in this moment is how to serve data in a way that's easy for an analyst to consume. And then the next step above that is how to make it easy for a machine learning application to consume. This is really hard because most of the data architecture that we've had up to this point has been around relational stores, really strict schemas, it's really structured. And then we thought all of a sudden, okay, I want to do videos now. I want to do images now. I want to do audio. And it's just like all of this application data, it's really messy. There's a lot of different formats and it's unstructured. So if we go to the 1970s, probably sometime around when when Tim was around, we had a lot of results kind of moving from how do we take operational source data and how can we make it make sense to people through these logical models, right? And that's kind of like where we ended up going, okay, we want to be able to use SQL to query a lot of these things. And through SQL, we went into data management. And then ETL. So ETL stands for extract, transform, load. I have a bunch of data in like a source system derived from an application. It's not quite ready to build a report off of yet, so I need to kind of manage it or transform it in some way so that it makes sense, that I can build my crappy little histogram so that my executives can feel okay with what we're doing at work. And essentially, from there, that executive decided, okay, I want to now have this statistic for every single thing in the company. And then we as data engineers went, oh my gosh, we have so much data that's just all around these different parts of the applications with this crappy Microsoft application. Not that there's anything wrong with Microsoft, but we've worked with a lot of Microsoft applications. And this legacy application and like these documents that people have been signing, and it's just, data's just everywhere, right? Data is really subjective in that way, in that anything can really be a piece of data if you want it to be. And we thought, we're just gonna dump it all in one giant place and call it a data lake. What could go wrong? Just because you're not managing data at scale while it's across these different applications doesn't mean that putting it in one place means that it's all of a sudden going to manage itself. Things got really messy. And in the 2010s, a lot of companies experienced what was called the data swamp, where we put all of this unstructured and structured data together in the same place, and it was a mess. Nobody knew what was going on in there. We just do our little query and pray for the best that it won't break. And that's kind of where we're seeing a lot of bad hygiene in terms of data management be punished. And that's what a lot of companies are actually going through right now. Take it to the 2020s, AKA present day, and we're kind of deciding, okay, this data lake thing is not working for us. None of the analysts can work with it. We have a bunch of transformations because you're taking data out of the data lake. You're going, okay, this is not exactly what I need. I'm going to clean it in some way, and then I'm going to clean it, and then that's it. The clean data is living somewhere else, and nobody knows what that is, and people are doing redundant work trying to copy that over. and it's not very governable. And when we talk about governance, we talk about how do we actually manage this in a way that's audible? How do we make sure that the people who are supposed to access it can access it? If the government tells us, hey, you need to delete all this data and all the assets around this particular person, we can do that efficiently. That's kind of what that means. And so we're moving into this idea of data, fabric, and mesh. And really the idea here is that we're moving into platforming data. How do we actually create a platform where instead of this giant lake that people pull from, can we provide a layer that people can actually serve? We're gonna get into that a little bit more. These last two humps were just because I couldn't figure out a way to actually truncate this chart, so I had to come up with some BS to fill it. But I'm gonna tell you guys what it means anyways. What we're noticing right now in the data community and just generally is that open source is a huge part of data infrastructure because it's cheap, it's easy, you just deploy it, there's a large community. People really hate vendor lock-in these days. But what that means is that there's a lot of standards. I think the software engineering community and the web development community have come up with a great number of standards that have been adopted. But in data, we're going through this learning curve of like, what are we actually going to adopt as a standard? And it's really hard. One of my favorite things about standards is that there's 20 of them, and you get to pick and choose which standard you think is best, which it kind of negates the whole point of a standard. So ideally, after we're through this hump, and after AI gets more, sophisticated and takes all of our jobs, the data will always be perfect and we'll never have to think about it again and we'll never have a conference like this anymore. When that happens, I don't know. So let's talk about a data lake. I kind of went over some of the basics, but generally you have a ton of operational data that's in a single place. So this can be your application, it's generating data in sort of these different machine formats. And then you have a data engineer that builds a pipeline. So I'm going to write some sort of script that takes in all of this data, and then that restructures or models it, and then cleans it up in a way. So maybe remove some of the null values, checks the distributions, sees that the data is correct, and then puts it into a place where analytics people can consume it, including machine learning applications that are training it, other lake houses or warehouses that other BI analysts can pull from, and of course data scientists, right? This is kind of what we've known. If you take a look at the data pipelines, you'll see that there's a lot of branching that happens here from the source data. And this is one of the issues that we have with the data lake format is that some data engineer might have gotten the request from a data analyst that, hey, this data is not the format or cleaned in a way that I need it to. Can you prepare the data in a way that I can analyze it? Data engineer builds what's called an ad hoc pipeline and goes, okay, let me go build that right away, and then never looks at it again. And then that just gets orphaned, and then nobody ever looks at it. Or another data engineer and another data analyst do the exact same thing and build the exact same thing, but somewhere else, and nobody ever talks to each other. This is really hard from a management perspective. So this brings us to this idea of project-driven versus product-driven data analytics. So in a project-driven analytics platform, it's kind of like those ad hoc requests that are coming in and they're working backwards because you have the C-suite going, I want this project done, I need to know this data and I need to back it up so that I can convince whatever amount of money to spend on it. And then the data analysts go, okay, let me create this report for you. And then they go, hey, I need this data. They go to the data engineers. Data engineers are like, okay, let me find this data. And then that's what the project is, right? I kind of just went over a lot of that. With product-driven data analytics, what we're seeing is that things are being broken up into different business domains, and then the data products are managed in a way that's already meant to be served. So if you're treating your data like a product, you're actually preparing it, and you're structuring it in a way that's meant to be taken by somebody else. We call this a data marketplace. Literally just like any other marketplace, like if you're shopping on Amazon, where you're searching a portal and you're going, oh, I like that this data is available. Let me just add it to my cart and then let me check out. And it's all perfect and it works great and nothing ever breaks. That's kind of the idea. So data lakes were really meant to solve this problem of how do we address this large data revolution where all of a sudden we have these huge amounts of data that are working at the scale of FANG, like LinkedIn or Google, and how do we actually put it in a place where people can analyze. But Mesh and Fabric, and you probably are getting the sense now, it's really meant to deal with the problem of access. How do we actually get people to efficiently use this data in a way that makes sense? So how can those consumers access data quickly because they want to have that data and have it now? How can we format it so it's consumable and it makes sense for the way that they're consuming it? So how can we create data models that make sense this way? How do you also have consistency between data and AI governance, right? If I'm the government and I want to go, hey, how did this chatbot create this answer, and did it use anybody's private information? As a company, you need to be able to give an answer. You can't just go, I don't know. But that's kind of the state of where things are at right now, right? So if we look at the concept of Mesh and Fabric, and I'll go over Mesh in more detail because it's a new concept for a lot of folks. Really, you're thinking about a mesh like literally a spider web where you have these different data products in this marketplace that's maintained by different domains. And then a fabric is literally a single layer. So it's like a platform that people can pull from. When you're thinking about data mesh, really the differentiation here is that each domain is responsible for like really putting together a data product that can be serviceable to the rest of the company. Whereas a data fabric is like, okay, let me have all of like a single engineering team that's responsible for serving all of the data at once, and they're responsible for that. There's pros and cons to each one. But again, really the idea here is how can we like streamline all of this to make the access easy as well as to expedite the consumption. Okay, let's go more into data mesh and let's get into kind of the weeds here. Data mesh really pulls from this idea of domain-driven design. Pretty straightforward, but it sounds complicated if we have different domains within an organization, like an HR domain, a sales domain, an application domain, something like that. How can we then empower those domains to serve their own data? And how can we design our architecture around the idea of these domains instead of just going, okay, all data is equal, it's all engineering and IT. The way that we implement microservices in this is that, okay, how can we write a service then that makes this data available at all times so that people can just call it using an API or something like that? And this is kind of what the mesh is. So if you look at the top right corner, this image is from Confluent, which is the Kafka company. And what they assume is that, you know, different domains that are highlighted in these circles here will actually serve up different streams of data that then others can subscribe to. I won't get too deep into the weeds of Kafka here, but that's kind of their idea of how you would implement a data mesh, right? And so it's important to note that mesh is how you organize the data from a logical standpoint in terms of human readability, but not necessarily in terms of how you store the data and partition it. So it's important to keep that in mind. The idea of data mesh is really inherently socio-technical, which is a cool, concept of like it needs the people to work and it needs the technology to work together. And it's business data as really, the main concept here. This idea of data mesh was really meant to serve business use cases, not necessarily machine learning use cases, which is an important distinction. But again, it's meant to eliminate that process of having to go back to the data engineer to create all of these ad hoc pipelines, which can then be really inconsistent. I also want to say here that just because you're moving to data mesh doesn't mean you're removing the complications of a swamp. And if you had bad hygiene in the swamp phase of your data architecture, data mesh is probably going to be way harder for you to implement, and it's way easier to mess up. So if you look at kind of like the number chart here, really it's only at maybe step 5 that you're gaining value from having a data mesh. Can you successfully implement data mesh? Can you successfully get your teams to do it? We're going to get into that. So this is the very high level of what data mesh is. Hopefully that makes sense. So what does data mesh look like in practice? So again, I talked a little bit about that data marketplace, which is in the highest level, and it's really like, okay, different business analysts, different applications, different data scientists or machine learning applications are going to self-service from these different domains, and they're going to shop for the data. But these data products themselves are, again, they're organized by the domain. So an HR like data product might pull from multiple different sources. That's important to note, that it's multiple applications, like maybe Salesforce, maybe an HR software, that both get consolidated together to create this data product. And there's dedicated data engineers within each domain that are actually responsible for like preparing this data product in a way that is always consumable and always ready and always clean. And those include, data domain owners, and then you replicate that across each domain. So the important thing to note here compared to a fabric is that each domain has its own data engineer and its own data product owner. So these guys are actually not necessarily working together in the same way that a traditional engineering team would. If you expand this out a little bit, you can see that there's a lot of things that also run parallel to data mesh that are required. You require federated governance, and when we talk about federated governance, what we really mean is that each domain here is responsible for auditing and managing their own data because they're responsible for their own data product. It's not like all the data is pooled in one place and then we just do governance on that one single place. But you also kind of need a platform team to platformize those data products and make them accessible. And with that comes a lot of different things here. And obviously I'm a little bit biased to that catalog, but generally speaking, when we talk about observability and monitoring, we want to talk about how can we measure the distribution of this data, how can we make sure that it's correct, how can we detect and alert ourselves to when things go wrong. So a data fabric strategy, in turn, is a little bit different, where the concept is that you have a bunch of metadata and you're empowering different pieces of your architecture using this metadata to create a fabric. And this fabric is what everybody interacts with equally. Sort of like if you took the concept of the marketplace, but instead of having these different domains broken up, it's one engineering team maintaining this fabric. And so the focus of this is really around the technicalities of this. How can we join all this data on a technical level and then make it work in a lubricated way? And so, of course, you have to have some sort of level of automation in there. You're really focusing on more of the DevOps side of things, where it's, okay, we have all this data that's being pulled in. How can we automate that process of continuously pulling in this data? And then, add these really cool things like lineage, which is, tracing a piece of data through its life cycle in terms of the different transformations it's undergone in an end-to-end way. And really the idea behind Data Fabric was to create a fabric over top of different clouds. So if I have data on GCP and AWS and maybe on-prem somewhere, can I create a single layer that negates the fact that this data is split up in different ecosystems and then serves it in a way where the end user won't be able to tell the difference? So again, I mentioned before that I'm part of a data catalog project, and our idea is kind of around this idea of data fabric, where you might have different query engines like, say, SQL, Spark, different platforms, especially in the Python ecosystem, for instance, like PyTorch or TensorFlow, that can directly pull from this data fabric, and this data fabric is empowered by metadata. And so what is metadata? Well, honestly, when you have a lot of different data sources, those data sources will produce their own types of metadata. For instance, in a Hive architecture, so if I have Hadoop, which is a distributed data storage system, I will have data stored across many different data centers and in many different formats, well, not many different formats, but generally speaking, it's spread out because I want to be able to efficiently store it to save my company costs. In Hadoop, you have something called Hive Metastore. Hive Metastore is a store of metadata that points to where each piece of data actually lives. So I might have a particular table from HR, and if it's large enough, I might want to distribute that data in small bits across many different data centers for the reason of like having it always available, to have it replicated across many different systems, and to make sure that it's cheaper to store it instead of putting it all in one data center and going, that data center contains all of our HR information, it now has to be kept alive at all costs. Fun fact, if any of you play Call of Duty, Activision has their entire data center in one place in Las Vegas, and that's the building where all of your gaming data is, which is very different. They do use Hadoop and Hive, but that's kind of like the opposite of what we're trying to go for. And so if you took that idea and you applied it to different types of stores. So let's say I had streaming data, I had relational data, and I had machine learning data or models that I wanted to use the metadata for. Could I pool all that metadata together to then be used in this fabric? And so hopefully that makes sense for folks. And then ideally, I could query that data using the metadata itself, and then it can point to where the underlying systems are. So to recap here, because I'm sure you guys are all data mesh experts at this point, data mesh is around the domain owners. It's really the business first, and it's around these domains, and it's around the logical characteristics of how we conceptually, as humans, group data in terms of being HR data, application data, or sales data, et cetera. Whereas a data fabric does not care about any of that, and it's all about how can we technically pull together all of the data in a way that's easily servable from a very fine-grained level. And it really thinks about the physical characteristics of the data. The goal of a data mesh is to have your marketplace. That's really the gold standard. So if you can get to the marketplace, you've successfully implemented data mesh. Whereas a data fabric is really about linking these pieces of data together physically in what can be known as a knowledge graph. I won't get too much into knowledge graphs, but it's really important to be able to know how different pieces of data relate to each other in this larger production use case. So the owners of a data mesh and those data products are really in terms of domain. So in each domain, you'll have your own dedicated data product owner and dedicated data engineer, whereas a data fabric is your IT department, it's your data engineering department. It's structured very differently on an organizational level. Now the kicker here is that you can actually have both. And in my opinion, you actually need the data fabric in order to enable data mesh. This is really complicated, so don't stare too, squint your eyes a little bit because it's so much information. But generally speaking, the TLDR is that in order to actually do a data mesh, you probably need a data fabric anyways, because you still need to conjoin and process that data at the low level in some sort of way. And then once you have it all technically put together, you can then throw whatever domains you want on top of it and organize it in whatever way you feel is necessary. And the cool thing is that depending on your use case, so let's say I'm trying to build a generative AI application that takes all of the data in a machine learning friendly way, I can actually pull from the data fabric directly. Whereas if I have an analyst and I want to produce a report, I might be more inclined to use a data product because it's actually easier for me to consume that. So again, kind of to show how this might look, and a lot of this is the same information over. If I am using a data fabric, I can actually auto-generate, using machine learning or using AI, different data products depending on how we're grouping them. And then we can govern on top of that, and we can have domain ownership on top of that. But underneath it will be some sort of fabric anyways. This is the same thing, but pivoted a little bit, and I know that you guys have seen this before, but the data fabric is really under that data platform section. And one of the cool things about this is that that federated governance can also be powered by the data fabric in some sort of way. There are caveats, of course. The first is that data mesh is led by and is bottlenecked by people. And as technical people, we really hate other people who are especially not technical sometimes. It requires hygiene in front of everybody to have at the same time. And it still requires a data fabric and a data catalog. You're also going to have a tool sprawl that happens when each team has their own way of managing that data product and serving it, and so it can be really costly. And the idea that instead of having this monolith like a fabric, you're actually producing a bunch of different microservices that act as these data products, which can be really tough. So there's a little chart there that kind of shows what some of the caveats are there. And a data fabric is also liable to swampage, just like a data lake. It needs to be maintained. And you actually risk a lot of qualitative information because domain owners know their data best. And having an engineer who works with all the other data will not understand the specifics of that data that they're working on, which is why data mesh is really useful as well. So I'm going to skip over this, but generally the value proposition here is that if you have a technical team, you want them working on the fabric, and they're really, again, focused on serving this data in a platformized way, whereas the business team will gain more value out of a mesh. So if you want to think about if your organization requires one or the other, this is kind of where to go with it. And of course, you have to think as well, is my team even capable of delivering a data product? It can't just be like HR that delivers that data product. It also has to be sales. It also has to be like different parts of your engineering teams that are capable of this. You need everybody on board. Otherwise, you have a partial mesh, partial fabric kind of messed up thing and orphan stuff, and it's really complicated to then work on. So key questions here, of course, and decentralized development is definitely not cheap, so it's not easy to do this. So if you're already having governance issues, I have a solution for you, and that's that cataloging is a really good answer to this. Generally, governance covers security down to compliance, down to availability and provenance, and of course, ownership. So if we look at different data governance models, a centralized governance model is around just managing the data in that fabric. Decentralized is around the mesh. But you can have a hybrid model depending on what works best for you. So some domains are better off having, or some facets are better off having like a universal model applied, whereas others might be better off like just in that specific area. Healthcare is a really good example of this, of course finance as well. And depending on whether or not you're going with a hybrid strategy, you might have different owners for the different parts of that governance. Okay. Little plug for Gravitino, because I know we're running out of time, but I wanted to make sure that we got the mesh and the fabric stuff right. Generally, Gravitino, like I mentioned before, is about creating that pop-up fabric across different assets. So let's say you might have a relational store in MySQL, you might have objects in S3, and you might have Kafka topics. You can use and register the metadata as a catalog within a single layer and then have that storage abstracted out. And then within the functionality of Gravitino, you can perform your governance and you can do everything that you need to then serve and empower either a fabric or a mesh, depending on what's right for you. We, of course, serve as an API, which makes things really straightforward and easy. And if you're interested in this, I'm happy to talk about it more. And we do federated querying. And so what this means is that I might have a SQL query that takes data from Japan and America, or AWS and GCP, and I can actually have the query split up into two. And then the processing happens in place, and I can tell the government, hey, I didn't move the data at all, it's all compliant. Which is really great because your analyst or your data scientist will not care about that whatsoever. Again, just kind of hashing that as well, and you can introduce tagging and masking in this as well, so you can have privatization if you need to, and you can tag it in a way that's more machine friendly. So in terms of actual AI stuff, the way that I see it is that you can actually have AI systems sit on top of Gravitino and pull from that fabric in that protected, governed way, instead of just having this free-for-all connectors that are just going in and out, and then you're manually connecting to these different systems. So in the index there, you can see that there's Llama index, and usually what you would do is you would manually build connectors into Llama index to build your index and then vectorize off of. But here you have this layer of protection where Gravitino can say, hey, Llama index, stop. You can only access this data, and this data, and this data, and we're gonna make sure that everything is protected. And your teams can deploy as many different indexes as they want because they're just gonna pull from Gravitino anyways, instead of having to build those connectors over and over again. So I'm gonna skip over this, but generally it's just saying that we support Python ecosystem. And the general idea is to make the data engineering teams and the data scientist teams work more easily with each other in a governed way where you can have this cross collaboration. So yeah, if you're interested, you can scan that QR code. It goes to our community. We also are under the Apache license, so you can use it and remix it. Just search Apache Gravitino, and you can find our repo, and you can find our social media as well. And yeah, so feel free to reach out to me at any point if you need to. Thank you. I don't know if we have time for questions, but.
The next one's supposed to be going at 3:05, but we have a 10-minute break. We can buffer maybe like a few minutes, maybe a couple of questions.
Yeah, if not, feel free to reach out to me on LinkedIn or just talk to me directly. Yeah. Yeah, so the question is, if you wanted to move to data mesh and away from ELT, how can you do that in a safe way? Yeah, I should put this on the caveat before I'm burned at the stake. You will never get rid of ELT. There's always going to be messy data that you're going to have to process in some way. But generally speaking, I think it starts with really identifying what a lot of that ELT is going to. Is it just moving data from one place to another, or is it actually cleaning data? And I think a lot of it is, okay, if we can identify these pain points, how can we abstract it out and then solve it with mesh? So it really depends on what the ELT is doing because it's such a broad term. Yeah. But generally, you will have some form of both. Like those data engineers within the business domains will still do some ELT. It's just within that specific section of the company. Yeah. Any other questions? No? All right, well, thank you.